Hello, this is the lecture number 10 for the chapter integration, and we were discussing the last lecture, the exercise 7.5, which based on the making integration by making the partial fraction, and we'll discuss it again in this lecture. In the second question, we have integration of dx upon x square minus 1 and x square minus, we can write it x square minus 1 square, which will be the special integral. We can do it like that also, dx upon x square minus a square, which is 1 upon 2a log x minus a upon x plus a, which is a special integral. Or we can make into a partial fraction and integrate in the partial fraction. How can you do it? For x square minus 1, you can write x plus 1 x minus 1, and it is a partial fraction of first type. So you let it this 1 upon x minus 1 x plus 1 as a upon x minus 1 first factor plus b upon x plus 1, that is second factor. Taking the LCM in the right hand side, adding, the denominator will be cancelled out, and we are getting a x plus 1 x minus 1, as we have discussed in the last lecture in question number 1. First of all, put x is equal to 1, then you put x is equal to minus 1 in this equation. You will get the value of a and b. Now if you put x is equal to 1 in this equation, this will be 0 and a into 2 will be equal to 1. The value of a is half. When you put x is equal to minus 1 in this equation, this will be 0 and b into minus 2 is equal to 1. The b will be equal to minus half. Replace the value of a and b here like this. It will be an integration of 1 upon x minus 1 and 1 upon x plus 1. This is half log x minus 1 minus half log x plus 1, taking half common, and by using the property of the log, when we have the minus sign, it will be divided. That is log x minus 1 upon x plus 1, which is same as I have told you to do it directly with the special integral like this. So whole exercise is based on this partial fraction questions, whether it is a first type or the second type or a third type. In the question number 3 is also a partial fraction of first type, but it have three factors. So it is 3x minus 1 upon x minus 1, x minus 2, x plus x minus 3. Let it equal to a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. That is a upon first factor, b upon second factor, c upon third factor. Taking the LCM in the right hand side and arranging, the denominator will be cancelled out, and you are getting 3x minus 1 is equal to a into x minus 2 x minus 3, b into x minus 1 into x minus 3, c into x minus 1 into x minus 2. First of all, put x is equal to 1, then put x is equal to 2, then put x is equal to 3. In this equation, you will get the value of a, b, c. When you put x is equal to 1 in this, you are getting a as 1. When you put x is equal to 2 in this equation, you are getting the value of b as minus 5. When you put x is equal to 3 in this equation, you are getting the value of c is equal to 4. So a, b, c you have obtained. Put these a, b, c here, a upon b upon c upon, you are getting this integration, and the integration of this is very easy. It is log x minus 1, this is log x minus 2, this is log x minus 3. So this is log x minus 1 in the modulus minus 5 log x minus 2 in the modulus plus 4 log of mod x minus 3 plus 3. This is question number 4 is also just as same as 3. It is the partial fraction of the first type. You let it equal to a upon x minus 1, b upon x minus 2, c upon x minus 3. Adding in the right hand side, denominator will be cancelled out. When you put x equal to 1, then put x equal to 2, then put x equal to 3. In this equation, you will get the value of a as half, b as minus 2, c as 3 by 2. Replace this a, b, c here. A is 1 upon 2, b is 2. This is minus 2, c is 3, and you can integrate it as half log x minus 1 minus 2 log x minus 2 plus 3 by 2 log x minus 3 plus c. Now it is question number 5. It is see it carefully, 2x upon x square plus 3x plus 2. Now this question you can do as in the last exercise we had done, linear upon quadratic type form, making it a special integral, but I am doing it here by using the partial fraction because I can factorize the denominator. It is x square plus 3x plus 2. I can factorize it. It will be x plus 2 x plus 1. So it comes out to be a type of partial fraction of first type. You can do it by linear upon quadratic question type as we have done in the last exercise of 7.4. 4. So let it equal to a upon x plus 2 plus b upon x plus 1. Adding the right hand side, the denominator will be cancelled out. If you put x equal to minus 1, you'll get the value of b. When you put x equal to minus 2, you'll get the value of a. And put it here as usual, you'll integrate. Or you can do it by making a perfect square, that is using the special integral linear Poisson quadratic type. So try to make in the numerator the derivative of the denominator, which is 2x plus 3. So 2x is already there, so you have to only add and subtract 3. Separate into two integral. In the first, it contain in the numerator the derivative of the denominator and minus 3 upon this. This is when you let it equal to 2, this will be cancelled out, it will become 1 upon t, and in here you make it a perfect square by adding and subtracting the square of half of coefficient of x, which is 3, that is 3 upon 2 whole square plus minus. So this you can do by making the special integral of this question number 5. You can do it by making up a special integral. So this is the first type partial fraction in which we have only linear factors in the denominator. Now in question number 5, first of all see it very carefully. Now this integral is 1 minus x square upon x 1 minus 2x. It is a improper fraction. Why it is an improper fraction and what is the improper fraction? When the degree of the numerator and the denominator is same, or if the degree of the numerator of the polynomial in the numerator is more than the degree of the denominator, then it is known as the improper fraction. So before integrating it, whenever we have an improper fraction, first of all you have to integrate it and convert it into a proper fraction. Now what is a proper fraction? Proper fraction will be when the degree of the numerator will be less than the degree of the denominator. So how can we convert into proper fraction? By dividing the numerator by the denominator. The numerator is 1 minus x square and the denominator is minus 2x square plus x. I have arranged it. Now you know how to divide the polynomial. When you multiply it by half, you'll get x square. This will be cancelled out. So its quotient is half and the remainder is 1 minus half x. Now proper fraction is always quotient plus remainder upon divisor. Quotient is half, remainder is 1 minus half x, and divisor is minus 2x square plus x, or x into 1 minus 2x. So this is quotient plus remainder upon divisor. Now this is the integration of this. Now you can integrate easily half, which is half x. Now this you have to integrate by making the partial fraction, and it is the partial fraction of the first type. So let this is equal to a upon x plus b upon 1 minus 2x. Partial fraction you have to make it. So first of all, when the degree of the numerator and denominator is same, it is improper fraction. So you have to divide it and make it a proper fraction and write always in the form quotient plus remainder upon divisor. Then it will be a proper fraction. This you can integrate easily. Now this you have to integrate by making a partial fraction of first type. It is a upon x plus b upon 1 minus 2x. Adding in the right hand side, the denominator will be cancelled out. When you put x equal to 0, you will get the value of a as usual. When you put x is equal to half, see it here very carefully. When you put x equal to half, you will get the value of b, which is 3 by 2. Replace this in the partial fraction, which is this. So this comes out to be 1 minus half x upon x 1 minus 2x half. So this partial fraction is a upon, which is a is 1. A is 1, so 1 upon x plus b upon 3 upon 2, 1 minus 2x, because the value of b is 3 by 2 here. Partial fraction of this is a upon x plus b upon 1 minus 2x. Integrate is, it is half. You know the integration of 1 minus x, that is log of this, and the integration of this, see it very carefully. 3 by 2 log 1 minus 2x divided by the derivative of 1 minus 2x. It is a polynomial, but the coefficient of x here is minus 2. So therefore, it is divided by the derivative of the denominator, which is minus 2. So it is a good question where you have to arrange it before integrating, and after before integrating, making it a proper fraction and then integrate. Now question number 7 is a partial fraction of third type, where in the denominator we have a quadratic polynomial which cannot be factorized. So this is a third type partial fraction where we have a quadratic polynomial of which cannot be factorized. So to be very careful. Now in that what you have to let? You have to let 1 upon x square plus 1 into x minus 1 is equal to linear polynomial in the numerator of this, that is ax plus b upon x square plus 1. I have told you in the beginning of this exercise, when we have a quadratic polynomial and the quadratic polynomial cannot factorize, and above in its numerator you have to put a linear polynomial ax plus b and c upon x minus 1. So always you have to let it like this whenever we have the quadratic polynomial which cannot be factorized in the denominator. So this is ax plus b into x minus 1 plus c into x square plus 1 is equal to 1. The denominator will be cancelled out. Now I am using the second method to find the value of a, b, c. Here in the first method we are put x equal to 1, put x equal to minus 1 like this to obtain the value of a and c. I am using the second method to find the value of ABC here. What is the second method? By equating the coefficients of the variable in left and right hand side. So I am multiplying, open the bracket. I have collected the term containing the x square, that is x square is, the coefficient of x square is a, plus c, the coefficient of x is b minus a, the constant term is c minus b. Now what is the equating the coefficient of in the left and right hand side? The coefficient of x square here is 0, here is a plus b, so a plus b equal to 0, b minus a is equal to 0. Again the coefficient of x is 0 in the left hand side, and the constant term in the right hand side is c minus b, and then the left hand side is equal to 1. So put it c minus b is equal to 1. You are getting three equations a, b and c. Now you have to use these three equations to find the value of a, b and c, which will get minus half, half and half. You take your own time to use the substitution method to find the values of ABC in ABC in this second type method to find the values of ABC in the partial fraction. Replace ABC here, A, B, C here, you are getting this. See it very carefully. AX plus B plus C. So A is minus half, B is half and C is half. Now you can integrate easily this half x minus a. You break into two integral. So you can take half common, minus half common rather. So x minus 1 in the numerator, and it is half 1 upon x minus 1, and integration of this very easy, which is log x minus 1, which is log x minus 1 of modulus. Now this is a linear upon quadratic type question which we have done in the last exercise. You have to make the derivative of the denominator in the numerator. The derivative of the denominator is 2x. So you try to make 2x in the numerator by multiplying and dividing by 2. So 2x minus 2 and divide by 2, it is 4. And separate it into two integral, that is 2x upon x square plus 1 and minus 2 upon x square plus 1, taking care of minus 1 upon 4. This. Say it very carefully. Now when you let this is equal to t, this will be cancelled out, and you should know that its log is its integration is log x square plus 1 mod x square plus 1. When you let this is equal to t, this will be cancelled out, so it is 1 upon t, and the integration of 1 upon t is log t, where t is x square plus 1. If you are unable to do it directly, you can let x square plus 1 is equal to t and then integrate. Similarly, this is the special integral of 1 upon x square 1 plus a square, which is tan inverse x, and this is the integration of the last. We have already done it here. This is half log x minus 1 plus 3. So you do this question at least 2 times to have a good command of these type of questions. We'll discuss the remaining question in the next lecture. Thank you.